So we are discussing the topic about expectation of a random variable in probability theory and statistic process. First, expectation of a random variable. In expectation of a random variable, the subtopics are expectation, expected value of a continuous random variable, accepted value for discrete random variable, special case, and examples using the expectation of a random variable. First, we discuss about the what is the expectation. The expectation of a random variable is the average value or mean value. So this means the expectation is the average value. The variable takes in long run when the experiment is repeated many times. So by using expectation, the experiment is repeated many times. It is also called the expected value or mathematical expectation. It gives the measure of the central tendency of a probability distribution. If x is a random variable, then its expectation is denoted as a of x or mu. It is weighted average of all possible values that a random variable can take, where the weighted are the probabilities. And the next topic is expected value for the continuous random variable. A continuous random variable takes is one that can take infinitely many possible values in some interval. Let's x be the continuous random variable with a probability density function fx of x, then expected value or expectation. E of in continuous random variable, the expected value is e of x is equal to integral minus infinity to infinity x into fx of x dx, where x is the value of a random variable, fx of x is the probability density function. The integral calculates the average value considering all possible outcomes. And the next topic is expected value for discrete random variable. A discrete random variable is one that can take infinitely many possible values in some interval. Let x be the discrete random variable and x1 and x2 infinity so on xn are the values of the discrete random values with their corresponding probabilities p of x1, p of x2, p of xn. Then the expected value in the discrete random variable, the accepted value is e of x is equal to summation I is equal to 0 to n xi into p of xi. Here, xi is the ith possible value of the variable, p of xi is the probability of the xi, and n can be the infinite or infinite. The next topic is special case of the expectation. The special cases of the expectation are when it's applied to the constants, linear combinations, indicator, variables, functions of a random variable, and independent products. They are used to simplify the calculations and appear frequency in the probability and statistics. In the expectation, equiprobable outcomes. The special case are the equiprobable outcomes. The outcomes of an experiment are called the equiprobable. If each outcome has the same frequency of occurring, that means if an experiment has n possible outcomes and they are equally likely, then each outcome has probability. This is the arithmetic mean of all possible values. E of x is equal to 1 by n of x1 plus x2 and so on xn. The equiprobable outcomes of the value is E of xn is equal E of x is equal to 1 by n of x1 plus x2 plus xn. And the next topic is in this past we are discussing about the expectation. The expectation is the what is expectation, and the expectation of the continuous random variable, expected value for the discrete random variable, and expectation the special case. If we are In this slide, we are discussing about the examples using the expectation of a random variable. First example is find the expected value of the outcome when a die is rolled. So here what we find is expected value of a outcome when the die is rolled. So x is equal to, so when the die is rolled, what are outcomes are appeared is 1, 2, 3, 4, 5, 6. So x is equal to 1, 2, 3, 4, 5, 6. Now since the die is a fair die, the probability of getting each outcome is equal. That is 16 61. So here we using the expectation of a discrete random variable function. So E of x is equal to summation of xi into P of x is equal to xi. Summation of xi into P of x is equal to xi. So by using this formula, E of x is equal to P of x is equal to 1 into 1 plus P of x is equal to 2 into 2 plus P of x is equal to 3 into 3 plus P of x is equal to 4 into 4 plus P of x is equal to 5 into 5 plus P of x is equal to 6 into 6. Here, by using this value, substituting these values in this formula, E of x is equal to 16 into 1 plus 2 plus 3 plus 4 plus 5 plus 6 into 61 into 1 plus 2 plus 3 plus 4 plus 5 plus 6. E of x is equal to 3. So final answer is E of x, and that is expected value of the rolled dice. The expectation is 3. And the next, this is the second example by finding out the expected value. So the problem is in a 3-time coin toss experiment, find the expected number of heads. Here what we find is 3 times coin experiment. Here the experiment is 3-time coin toss. Here we using a 1 coin or 3 coins. Here we using the 1 coin, it can toss 3 times. Here we using the 3 coins. Here 3 coins is tossing 1 time. So we can find the expectation of heads. In this experiment, what the heads are possible we get. So let the x be the number of heads obtained. So sample space is equal to, here we have 3 coins, 3 times coin toss. So here we have 3 heads, or 2 heads, 1 tail, or 1 head, 1 tail, 1 head, or 2 tails, 1 head, or 1 tail, 2 heads, or 1 head, 2 tails. This is the sample space of the expectation. So E of x is equal to summation of xi into P of x is equal to xi. So by substituting these values in this formula, E of x is equal to P of x is equal to 0 into 0 plus P of x is equal to 1 into 1 plus P of x is equal to 2 into 2. P of x is equal to 3 into 3. Where here 3 is, we are substituting because we use 3 coins. So we are substituting 3 times. Next, finding out the probabilities. So we are finding out the probabilities. P of x is equal to 0 is equal to 1881. P of x is equal to 1 is equal to 3883. P of x is equal to 2 is equal to 3883. P of x is equal to 3 is equal to 1881. Here we have E of x is equal to P of x is equal to 0 into 0. P of x is equal to 1 into 1. P of x is equal to 2 into 2. P of x is equal to 3 into 3. So by substituting these values in this formula, E of x is equal to 18.0 plus 38.1 plus 38.2 plus 18.381 plus 83.1 plus 83.2 plus 81.3. So by adding these values, E of x is 128812. So E of x is equal to 1.5. So thank you for this opportunity. And this is the total of expectation of a random variable in probability theory and statistics process. So we are discussing about what is expectation. The expectation is the average value or mean value. The expectation. So here two types: expectation for continuous random variable and a discrete random variable. The expectation of the continuous random variable is E of x is equal to integral minus infinity to infinity x into fx of x dx. So fx of x is equal to density function. Here the discrete random variable is summation of x into p of x. So this is the overall topic. Thank you.